Alright, today we're going to talk about merge sort, which is one of the most popular sorting algorithms out there. As always, we'll be using the textbook that I wrote. You can find it by going to the About section of the YouTube channel, and you can navigate to today's chapter, which will be, like I said, merge sort. So let's get right to it. So like I said, merge sort is a sorting algorithm. So to understand what merge sort is, we have to first understand what sorting is. Sorting is when you take a list of items, most commonly numbers like this, and you want to put it into a specific kind of an order. The most common type of order that sorting algorithms put things into is called an ascending order. So for example here, the list 3, 2, 5, 1, 9 is in no particular order. Whereas on the bottom, 1, 2, 3, 5, 9, it's called an ascending order because as you read the list from left to right, the items ascend, meaning they get larger and larger. So if we had an algorithm that took the list on top and turned it into a list on the bottom, you could consider that a sorting algorithm that puts lists into an ascending order. From here, let's assume that when I say sort, it means to put things into an ascending order. The reason we're talking about merge sort instead of some other sorting algorithm in this video is because not only is it simple, it also uses what's called recursion. So if you are taking classes at a university for a comp sci degree, this will probably be one of the first algorithms you learn that uses recursion. So it's a great intro material, but it also gets you exposed to a pretty important concept. And lastly, it's fast. So unlike some things you learn just for the purpose of the class, this merge sort is has pretty good performance. So it's pretty applicable to the real world. People use it, so it adds a little application in there. So what makes merge sort different from other sorting algorithms besides what I already mentioned? Well, so its goal is to sort a list, which is the same as any other sorting algorithm. But merge sort is unique in a sense that it tries to solve this goal by solving a simpler goal, which is to merge two already sorted lists. This idea of merging two sorted lists is crucial to understanding merge sort as a whole. So let's take some time and try to understand this merge operation in more detail. So here is what merge tries to do. Like I said, you start with two lists, list A and list B, that are already sorted. And you want to merge the two in such a way that the merged list, as shown here, contains every element that used to be in both of the lists that you started out with. And importantly, it's sorted too. So you take two sorted lists and put them together into a larger sorted list. That's all merge tries to do. So let's try to get an intuition of how merge works so that we can build on top of this operation to eventually get to understand how merge sort works. When I try to learn how algorithms work, I try to imagine, how would I do this on paper with my hands? So if I were to do merge with my hands on a piece of paper, what I would do is I would write down list A, I would write down list B, and have one finger on the first element of list A and one finger on the first element of list B. So the arrows on the screen represent my fingers. And what I do is I compare the two numbers on which I have my fingers. So in this case, which is smaller between 1 and 2? Well, 1 is smaller. So what I'm going to do is I'm going to write down 1 as the first element of the empty merged list. And I'm going to move the finger that I used to have on 1 over so that it's on 3. So I'm moving down the list because I already took care of 1. So I'm interested in the next element. And then I ask myself the same question again. So which is smaller between the two numbers that I have my fingers on? Well, in this case, 2 is smaller than 3. So this time I'm going to write 2 as the next element in merged list and move that finger over to 4. And we repeat this process. So 3 is smaller, so we write down 3. Now 4 is smaller, write down 4. Again, 4 is smaller. Now this is the stopping point for us, is when we have run out of items for one of the lists. You can see that our finger is no longer on anything in list B. We are out of elements for list B. So at this point, our job becomes a little easier. So we go to the list that we haven't run out of yet, so in this case list A, and because we know list A is already sorted, we can just start with the number that we have our finger on, in this case 5, and everything to the right of it, and we're going to take that chunk off and put it at the end of merged list. So in this case we're going to take 5 and 7 off and put it at the end of merged list. And after that, both of our fingers are off the lists, and we know we are done. So we have our merged list ready to go. It contains every element from both lists, and it's sorted. All right, now, so let's write a Python function that does exactly what we just did, which is the merge operation. So we already have list A and list B as the parameters of the function. So what we're going to do is we're going to create an empty list for the merged list, and we're going to have index A and index B, which are both going to represent our fingers that we used to have on the list. So index A represents the index in list A where we have our finger, and index B is for list B. So since we are going to start out by having our fingers on the very first elements of both lists, they both start out as 0. So now we have to write code to do that thing where we slide it one finger at a time, comparing two numbers and writing down the smaller number in the merged list. So I'm going to throw up this code up there. We're going to go through it line by line, so no worries, okay? So remember when we slid our fingers one at a time, we kept doing the comparing of the two numbers and putting the smaller number in the merged list thing only as long as both of our fingers were on the list, right? We stopped doing that when one of our fingers went out of the list, when we ran out of elements to go through in one of the lists. So the condition of the while loop essentially guarantees that. It's saying execute the body of the while loop as long as each index is smaller than the length of the list that they are kind of pointing to. So if the index is equal to or greater than the length of the list that it represents, then we know that our fingers are off of the list because the last element of the list is at index equal to the length of the list minus 1, right? So by having this condition, we are making sure that we are executing the while loop only as long as our fingers are on the list. We haven't run out of anything yet. And next two lines of code are, this is just for readability, so element A, is the element in list A at index A, and element B is the element in list B at index B. And the if-else block that comes next is where the actual comparison happens. So we are comparing to see which is the smaller element A or element B. So in this case, element A, which is 1, is in fact smaller than element B. So we're going to go into the if block, not the else block. So we're going to add element A to merged list, and then we're going to add 1 to index A, which essentially corresponds to moving our finger over from 1 to 3, advancing through list A. Now, since we're done with the if block, we go back up to check the condition of the while loop again. And in this case, both the index A and index B are less than the lengths of their respective lists, so we are all good. We're going to go back into the body of the while loop now. So again, we're going to give names to each of the elements that we have our fingers on, and we're going to compare again, is element A bigger than element B or vice versa? And in this case, element B is actually smaller. So we're going to go into the else block this time. We're going to add 2 to the merged list, and we're going to add 1 to index B. So in this case, we're going to move the arrow, our finger, over from 2 to 4 in list B. And same thing, we go back up, check the indices, we're all good. Both of our arrows, our fingers are in the lists. Now compare again, this time element A is smaller. So add 3 to the list and move the arrow over to 5. And like I said, we're going to repeat this process until we run out of elements in one of the lists. So feel free to pause during this segment of the video to give yourself more time to see what's going on. But the loop will come to a halt pretty shortly right about here. You'll see that list B, the arrow has gone out of list B. We ran out of elements from list B. So index B is equal to the length of list B, which means that the condition of our while loop is not satisfied. So we're going to break out of that loop. We're done with loop 1. Now remember what we did when we did this on paper is when we ran out of elements from one of the lists, we went to the one that we haven't run out of. We grabbed every element, including what we had our finger on, until the end. So grab that back portion and put it into merged list. So in this case, we want 5 and 7. We want to take that chunk off of list A and put it to the back of merged list. So now let's see how we can do that in Python code. So this is loop 2. It's a shorter, simpler while loop than loop 1. Essentially what we're doing is as long as index A is smaller than length of list A, meaning as long as there is still an element in list A that needs to be processed, we're going to grab it, we're going to put it to the back of merged list, and we're going to move the arrow over. So it's kind of like loop 1, but we're not doing any comparisons. We're just going to go through list A and put everything to the back of merged list until we run out of things. Now at this point, we ran out of things in list A. So we exit out of the while loop because the condition doesn't hold anymore. So at this point, the problem of merging list A and list B is done for this specific example. But it's not done really, because in this case, we ran out of list B first. So list A was the one with leftover elements. But what if we ran out of list A first and list B had leftover elements? Then we would need to do something like loop 2, except for list B, right? So if we had leftover elements in list B, we would want to go through list B and add everything that's left over to the back of merged list. So that's what this loop does. It's almost identical to loop 2, except that we're working with list B and index B rather than list A and element A. And we're done. So we just return the merged list and we are done with merge. So just to review what we did. In loop 1, we went through both list A and list B, comparing elements one at a time and building up merged list until we ran out of elements from in one of the lists. And then loop 2 and loop 3 take care of cases where we have leftover elements in either list A or list B, and then we simply just take those and put it to the back of merged list, and then at that point we are done. Now that we have merge down, there's just one more thing that we have to talk about before we can understand merge sort, and that is recursion. And functions that use recursion are called recursive functions, and they are functions that basically call themselves. So here is an example of a simple recursive function, which is a function that computes the Fibonacci numbers. You don't really need to understand what Fibonacci numbers are or what this function is doing, but the only one line that I want you to pay attention to is the last line here, where notice that the function Fibonacci makes a function call to Fibonacci, which is itself. So this is what recursion is inside of a function, it makes a call to a function which happens to be itself. And since merge sort is a recursive function, we need to know how to write recursive functions. So recursive functions usually have a base case and a recursive case. Base case is the portion of the code that does not make the recursive calls, whereas the recursive case is a portion that does make recursive calls. So recursive functions usually look like this. There's usually a conditional expression here. It says base condition. So this is a condition that if it evaluates to true, that means that the problem can be solved by just using the base case without making any recursive calls. Whereas if that condition is false, then it's necessary to make recursive calls, so we're going to go into a recursive case in the else block. It's important to note that you can't ever execute a base case and a recursive case. Usually these two are mutually recursive, and you'll either go into the base case or the recursive case, but not both. Alright, with that, we can finally get back to merge sort. So remember, merge sort tries to sort a list by solving a simpler goal, which is to merge two sorted lists using the merge operation that we just talked about. So the intuition behind merge sort goes something like this. So merge sort is a function that takes in a list, and you split the list into two halves. So left half and right half, called x's left and x's right in this case. And they're approximately the same size. Now we're going to sort each half. So we're going to sort x's left and we're going to sort x's right. And now here's probably the most important thing when it comes to learning recursion, and my number one tip for learning recursion, which is notice that we're making a recursive call here to merge sort. And we're not even done writing merge sort. So this is the point where people usually get confused because, we're trying to call merge sort, but we don't even know what merge sort does yet. So my tip is trust that it works. Assume that it works. Just assume that recursive calls will just magically do what it's supposed to. That's going to make your life a lot easier as you try to develop this recursive algorithm. So now that we hopefully agree that these recursive calls to merge sort will magically work, no doubt, here's what we have. We have the left half sorted. It's called x's left sorted. And then we have the right half sorted, x's right sorted. Now this looks a lot like the setup that we had for the problem of merge. We start with two sorted lists and we combine it into a larger sorted list. Now, merged list equals merge of x's left sorted and x's right sorted. So what do we know about merged list? Well, first of all, merged list contains every element that used to be in x's. How do I know that? It's because x's left and x's right were left half and the right half of x's. Those two got sorted, and so no elements were taken out or put in. So we know that x's left sorted combined with x's right sorted contain everything that used to be in x's. Now, the second thing we know is that merged list is sorted. How do we know that? It's because x's left sorted and x's right sorted were each sorted. And we know that the operation merge, what it outputs is also sorted. So merged list, kind of by the definition of how merge works, is sorted. So we have that merged list contains every element that used to be in x's and is sorted, which by definition is the sorted version of x's. So we're done. We return merged list and we're done with merge sort. Now let's try to step through what we just wrote for merge sort and try to see graphically what happens step by step. Alright, so when we merge sort an example list like 1, 4, 2, 9, 7 that's on the screen, what we do is we split it into two halves, and then we try to merge sort each one, right? So we have merge sort of 1, 4, which is the left half, and merge sort of 2, 9, 7 on the right half. So what I'm trying to represent here with this kind of drawing is that the problem of merge sorting 1, 4, 2, 9, 7 breaks into two smaller problems of merge sort 1, 4 and merge sort 2, 9, 7. And now trying to merge sort 1, 4, it again breaks down into two simpler problems of merge sorting 1, which is the left half, and merge sorting 4 on the right half. And yet again, in order to merge sort 1, we're going to have to split it into two, and merge sorting 1 turns into merge sorting 1 and merge sorting an empty list. Now, this might raise you an eyebrow, and you might think, how do you split a list of one element into two halves? Well, it depends on what you want and what your programming language is like. But if you're trying to split a list of one element using typical Python code, you will typically end up with itself and an empty list. Okay, but we kind of have ourselves a problem because we're not making any progress, because merge sorting 1 requires you to solve merge sorting 1, which just keeps on going. There's no stopping point, and this is expected. The code that we wrote for merge sort is not complete. It doesn't have a base case. Base cases give recursion a stopping point, and because we didn't write a base case into our merge sort, that's why our tree just keeps on growing and growing like you see on the screen. So to fix this issue, let's write a base case. So here is the same algorithm from before, and on top right, is just a reminder that most recursive algorithms look like that. So we're going to modify our code slightly to fit it into that pattern. And here it is. So what's in the else block is exactly the same as what we had from before. The only thing we added is the if length of x's is less than 2, return x's. And like I said before, base cases do not make recursive calls. And that is true for merge sort, because the base case is simply return x's, and it does not make recursive calls at all. So does this base case even make sense? Like, is it correct? Well, yes. So it's basically taking advantage of the fact that when you have a list of length less than 2, meaning it's either empty, which is length 0, and it's length 1, meaning it contains one element, it's already sorted by definition. So take examples like a list that just contains number 4, or a list that just contains number -2, and also consider the empty list. Well, things are out of order if you have at least 2 elements to compare. Then you can be like, the bigger element is in the front, so this list is not sorted. But if you have no elements or just one element, it can't be out of order, so it must be ordered. Alright, so let's try to revisit the example from earlier and see if adding this base case actually helps us. So just like before, in order to merge sort 1, 4, 2, 9, 7, we split it into 2. And then we split merge sort 1 and 4 into 2. Now here's where the base case magic kicks in. Remember last time when we were trying to solve merge sort of 1, we went into an infinite cycle where list of 1 breaks down into a list of 1 and an empty, and then breaks into a list of 1 and empty, and then it just never stops. Well, now, if you call merge sort with the list that just contains 1, it goes into the base case because its length is less than 2, and it returns the original list. So merge sort of just 1 is just a list of 1. And this is great. This is exactly what we were looking for. Instead of going into an infinite cycle, we stop. And using a similar logic, merge sorting a list of 4 just becomes a list of 4 now. And now we merge these two because a list of 1 is the sorted left half of 1 and 4, and 4 was the sorted right half of 1 and 4. And in order to get the final answer to merge sort of 1, 4, we have to merge these two. And merging 1 and 4 just gives us the list of 1, 4, and that is the answer to merge sort 1 and 4. Now doing the same thing here, merge sort 2, 9, 7 splits into 2, 9, and 7, and merge sorting 2, 9 requires us to merge sort 2 and 9. Now each of those hit the base case whose answers are trivial, and we merge the two to get the answer to merge sort 2 and 9. Merge sort 7 is also trivial, hits the base case. Now we merge 2, 9 and 7 to get the answer, and we're finally down to the last merge of 1, 4 and 2, 7, 9. And that is our final answer to merge sorting that big list at the top. So I went through that pretty fast, so definitely go back and rewatch the video to make sure you have a gut feel for how merge sort works. I know I left a piece out, for example, how to exactly find the left half of x's and right half of x's. So if you go to the channel, like I showed earlier in the video, if you go to the Practical CS book and go to the merge section, this is a complete working code for merge. And if you go to chapter 1.3, this block right here is a complete working code of merge sort. So feel free to copy those into your own files and try them out. Now, lastly, I'll go over the tips for writing recursive algorithms one more time. So the very first thing is you write the recursive case first. And the most important thing, assume that your recursion will magically work. So make recursive calls as many times as you want, trust and assume that it'll magically work. And then lastly, you want to write the base case to actually make that recursive case work and give it a stopping point like we saw in the tree diagram. So that's it for today. Thank you so much for watching, and I'll see you next time.